Okay, there we go. So we had our three tools on the toolbar that we can select. We can, when it's selected, we can click on the graph area here and drop shapes. So that's where we were at the end of last week. So this time what we're going to do is add a couple new tools. One is going to allow us to select a given shape and move it around by dragging. And then the other one's going to let us drag connections between them. So it'll basically make this into like a little graph. Okay, so first of all, let's go to our graph. And I want to take a look at our toolbar, which right now has these three buttons. So we have the square, the circle, and the triangle. And I'd like to add in two more buttons. One that is going to be for drawing a line. Now I called it line last week, but what I'd like to do is rename that because I'm actually going to have a data class called line that keeps track of the lines between things. So I'm going to rename this one to draw a line instead of just line. There we go. That's good over there. And let's add another one in here. This is going to be for select, which is another tool. And we need to define how these things are going to look on the screen. Now the selected tool and selected color works the same way for every one of these. The draw is what's going to be changing for each of these. So I'm going to change this guy to say draw line, taking that offset. And let's take a look at our draw functions and add in a draw line. And this one, we're not going to need to draw a line at a specific offset. We can just draw it. Well, no, we still just use the translate there. That's fine. So we only need one thing. There's no such thing as a filled line. So I'm going to get rid of one of those. Change this to say draw line. And he's going to have a start, an end, and a color, and a stroke width. So shape, outline, stroke. Is it just outline stroke PX? Let's see. Outline, shape outline with PX. That's it. Okay, so put him in there. Start and end are both offsets. And I'm just going to draw this line horizontally across the screen. So it's going to start from 0F at half shape size PX and go to shape size PX, half shape size PX. So it's just going to go halfway across the screen there. Shape outline color sounds good for that. So that should draw us a little line there. Let's take a look at what else we got. So he's taken care of. The rest of that looks good. And then for select, we're going to be drawing a rectangle. But instead of it being a rectangle that has a solid border, I want it to have a dashed border, so it's going to look a little different. So we're going to need to pass into him which type of border we want to use. Let's go to draw rect. Let's make sure we're choosing our we should draw square is what I called it. So let me fix that real quick while I'm thinking of it. We'll make that be draw square. And let's go to draw square. And we're going to pass in which border we want to use. So that's this shape outline stroke. So we're going to say outline stroke, which is going to be a stroke. And I'm going to default him to shape outline stroke, which we've defined earlier on. So if we don't pass it in, it's just going to be solid. But what we're going to do, let me tweak it down here to outline stroke, is when we call this for the toolbar, we're going to change it to be a dashed stroke. Now, in order to do that, we need to actually define that dashed stroke. And let's see, he's going to be, we need to add a couple new parameters. When we're doing dashed paths, we need to have a length of the dash and then a length of the gap between the dash. Now, depending on how you want to set up your dashing, you may have some kind of interesting pattern, like you might have a dash and then a space and then a dot and then a space, then a dash and then a space. You can do things like that. You just have to define, in that case, the dash width, gap width, the dot width, the gap width, and then it repeats. What we're going to do is just use a dash and a gap. So it's just going to be a very simple way of representing it. So we need to have inside of one of the parameters passed in here, let's say instead of shape size dp, we'll say dash, oops, width dp and dash gap dp. And let's make the width be 6 and the gap be 3, just like that. Now we're going to do the same kind of thing we did down here, where we convert those DPs into PXs. So I'm going to say dash width PX is going to be dash width DP PX and dash gap for both of those. Oh. Just like that. So we have those guys defined. We can now define a stroke. So what we've done so far is we have this shape outline stroke. I'm just going to make a copy of him, and we will say a dashed outline stroke. Same thing with the outline width. That's our only thing that's changing there. Oh, we do actually have the dash gap and then the dash length. So let's do our dash width px and our dash gap px. So if any of these guys change, then we're going to have to redefine this stroke. So this stroke, he's going to have the same width that he did before, but we want to add in a path effect. So I'm going to say path effect equals path effect, come here, dot dash path effect. And so we're going to pass in the intervals for that, which is going to be a float array. So I'm going to say intervals is float array of, and we're going to pass in, so dash path length, or dash width px, yes, and then dash gap px. Now we also need another parameter on this called phase, which tells you where to start inside of that. I think that starts at 0 by default, so I probably don't need to. Yeah. So this is actually the pixel offset into that intervals array. So where we start. This is useful if you're animating it, so that you can start at a given pixel space on the path and then draw from there. So if you wanted to animate it going around in a circle, you could gradually increase that phase, and I believe it's from 0 to 1. Or no, he's actually the full pixel lengths. So what I'm going to do is I'm going to go ahead and leave that as not defined because we don't need to define it. So there's our dashed outline stroke. And we'll go back to our tool buttons. And for the select button, I'm going to say draw square offset, passing in that dashed outline stroke. And there we go. So now that one should look like a dotted line on the toolbar. So let's give this a try and see if that's going to work. There we go. So now we have these 5 buttons. We've got a square, circle, triangle, the line, and then the select. Actually, did I want that to be filled in? I didn't want that to be filled in. Let's actually... we need to tell this not to fill. So I'm going to go to draw square, and let's pass in a fill parameter. And I'm going to default that to true, so most of the time it's going to be there. But if we say don't fill, then we won't do this first draw rect, which draws our fill. Okay, so let's go back to where he was defined, and I'll say fill equals false. Actually, let's go ahead and Put arguments on separate lines. And we will add names to the arguments. There we go. Okay, so that should be a little bit nicer looking. Let's take a look at him real quick. Make sure that's doing what I want it to do. There we go, that's better. So that's just the dotted line. If we click on these tools right now, they'll call the wrong thing. So let's go to yeah, so we have on tool change called, so it just changes the tool. So if we actually clicked somewhere with it, it's not going to do anything because we're not actually testing for that tool. So what I want to do is take a look at our pointer input that we set up. So we had done this before where we said I'm setting up a pointer input. I'm going to be detecting tap gestures. And notice that I had my when clause inside there. Now, this is going to be a little different for each of these types of tools. For dropping shapes, we're just going to be having a tap. And when you tap, we're going to drop a new shape at that spot. For drawing a line, we're going to be dealing with drags. So you're going to be dragging from one shape to another. For selecting, you're going to be dragging a specific shape. So each of these is going to have its own way of handling it. So what I want to do is, instead of doing pointer input with the when inside of here, I'm going to move this when outside and generate different pointer inputs. Now, when you're chaining functions like this, you can't really in the middle of it have something conditional. Unless you were to define some special functions, which you can do, kind of like a let function, but you might have a specialized when function that you define that'll choose different bodies based on something. But what we're going to do is a little bit simpler than that. I'm going to take the first part of this modifier, where we're defining the padding and the fill max size, which is going to be the same no matter what. I'm going to define him as a separate variable, separate property. And then, based on the when, I'm going to be adding in different pointer inputs to it. And there might be one pointer input, there might be two pointer inputs to them, depending on if we need to care about taps or drags or whatever. So I'm going to come out here, I'm going to say val base modifier equals, and let's just grab this first part. Just like that. And then let's say val canvas modifier equals, and we'll put our when in here. So I'm going to say selected tool. Now, because I'm outside of this pointer input, I don't actually need to use the ref to the selected tool anymore. We needed to use this inside here because detect tap gestures isn't a composable function. The pointer input one is defined as part of compose, and so he'll use this parameter to say if he needs to restart. We don't want to keep redefining tap gesture handlers because a tap gesture handler might currently be in use to keep track of where the user is dragging something. So we only want to have that defined once and then just keep reusing it. So if any of the variables inside of here change, that could be a problem because we wouldn't be redefining it. That's why we created these refs using remember updated state. And remember updated state keeps track of these guys indirectly. So whenever inside here I say anon shape ref or selected tool ref, it looks up what's the current value of the selected tool ref. And these guys are set anytime we actually come in here. So selected tool ref will get updated every time the selected tool is passed into them. Now we don't need to do that with the selected tool ref anymore because now we're just at the same level where selected tool was defined. So I can actually get rid of that selected tool ref and just say selected tool. And let's add in the conditions that we want to have there. So we'll just drop those in there. And what we're going to do is this is going to be defining a modifier extending off of base modifier. So if we're adding a shape, I'm going to say take the base modifier and do a pointer input on it. I'm going to pass in true, saying I don't want to ever update him. And then detect tap gestures. And we'll just move this guy into here. Now, this guy is again getting defined once because of this true here. So we do need to have this ref mentioned here. Oh, shoot, we actually did need the selected tool ref. Egg on my face. Selected tool ref. Let's do that again. I didn't even notice it was there. Selected tool. Okay, so now we can actually reference it. If we didn't use this as a reference here and never redefined detect tap gestures, the first time this is called, it would define the tap gesture handler, which is an object, locking in whatever the currently selected tool is, so that no matter what you picked, it's always going to drop a square in this case, because the square is the default one there. Now, because it's selected tool ref, he's going to indirectly look him up from that bucket up there. Okay, so he's good. We need to deal with the draw line and the select and the rest of this stuff. Now I'm going to tweak our canvas to just say modifier equals canvas modifier. And we don't need the rest of this. Just like that. So that kind of simplifies him a little bit. Well, I got one too many parens on the end. There we go. Let's see, do I want to get rid of this stuff? Yeah, I'm going to get rid of this stuff down here. Just to keep things a little cleaner. Okay, so right now we have this canvas modifier is the result of this when expression. So if it's a shape, it's going to be base modifier point input. For these other guys here, and I actually don't even need the curly brace on there anymore. I'm just going to say base modifier for each of these for the moment. And now if we look at canvas modifier, we'll see that he is a modifier. So when we pass him in as a modifier, things should work. So right now, things should behave the same way they were before. I'm going to go ahead and run it just to make sure. So we'll drop down the square, drop down the circle, drop down the triangle. Okay. And just for grins, let me actually show you what would happen if I just use selected tool directly there. So now I have the squares, going to drop them down. If I select my circle, watch what happens when I click. It's locked in that selected type. So by using that ref, it makes sure that we're always picking up whatever the current one is. So I'm going to go back to that ref there. So far, so good. So let's see what we're going to do when we try to do a select here. What I'd like to do is take that base modifier, add in a pointer input on him. I might as well just collapse that a little bit. There we go, less indented. And this one will pass in a true again for him. We're going to need to define a way to deal with drags. So when we're selecting things, we want to watch where the user is starting a drag, where they're dragging to, and where they're ending their drag or canceling their drag. Now, drags can be canceled if the finger moves off the screen or if they let up somewhere outside of our current bounds. In this case, we're taking up the whole screen. So I think actually if you let up inside the scaffold title bar, it'll cancel as well. Inside of here, we want to say detect drag gestures. Now there's two versions of this. One that has a very simple single a lambda called onDrag. There's another one here that has a bunch of other more specific functions in it. Now if we take a look, it's actually the same function. At least I believe these two are the same function, where the second one just has onDrag as its last parameter. All the rest are optional. And we can take a look at that real quick. Yeah, so we'll see that onDrag here, you have to specify it, but these other ones are optional and they're empty to start with. So that function can either be used just by detect drag gestures, curly brace, and then the onDrag, or detect drag gestures and specifically specify these, which is what we're going to do. So inside here, we're going to have onDrag start, onDrag end, and on drag cancel. Now, drag in and drag cancel, when we're moving an item, it's going to be the exact same behavior either way. So I'm just going to need to define in my view model one function for both of those. For these other ones, I'm going to have specific start, drag, and drag end. Now on drag here is not happy because he has multiple parameters coming out. If I float over him, we'll see that he has something called a pointer input change and then the current offset. This guy, let me check something real quick. La, 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 la. Yeah, no, I always, the drag amount offset I never use for anything. The change, which is telling us, this is one that tells us our current position. It'll be change.position. Offset tells you how much has been moved since the last time on drag was called. I was thinking for a minute there was a parameter that I didn't know about. So what I want in here is to add in, oh, that's not what I wanted. There we go. Let's start typing change. I'm going to add in change and drag amount, but I'm not going to use drag amount. Now, what you can do in Kotlin is just ignore it, in which case you'll always get a warning here saying it's not used, or you can explicitly change that to an underscore, saying I'm going to ignore that parameter. And that's actually a really nice way to do it because you're explicitly telling whoever's looking at this that you're not using that parameter at all. The only parameter we care about here is that change. So we need to define in our view model what we're going to do here. We're going to have a start drag, drag, and an end drag function. So let's bring up our view model. And let's come down here. Handle shape drags. And we're going to have a fun start drag. Fun drag. And a fun end drag. Now, end drag doesn't need any parameters because we're just going to be getting rid of any type of temporary data that we're dealing with. Drag is going to need to know where we currently are. So that'll be just an offset. Start drag is going to need a couple things. He's first of all going to need to know where the user put their finger down. So I'm just going to call that finger offset. We actually could call this finger as well. It doesn't really matter. I just wanted to explicitly specify that I'm dealing with where the finger went down. You know, I really should be consistent on those two. There we go, finger. Okay, so we need another thing in here. We need to say, I know where the finger went down, but I need to look up and see if there's a shape underneath that finger. In order to do that, right now, all I have is that position. I need to know how big that shape size is. So I'm going to have that get passed into us. The view model doesn't know anything about shape size. That's all inside the user interface. But we're going to use that inside of the view model to figure out which shape has been selected. So I need to pass it from the GUI to the view model. So I'm going to say shape size in pixels. It's going to be float. And then we need to figure out how do we detect which shape was actually selected. Now, when we do this, I need some way to find a shape based on an offset and a shape size. So I'm going to define a little helper function that I'm going to call find@. I'm going to pop this on out here. I want this to be an extension function, and you can't define extension functions. Actually, put them inside here. I'm thinking of something else. I'll come back to that later. We're going to define this as fun list shapes. So we're going to have it be an extension on a list of shapes. I'm going to call it find@. And this is going to be a really simple function. It's just going to look through the list of shapes to figure out which one contains the point that was selected. But there's a little trick here. When we look through the list of shapes, we have to consider which shape is topmost. So if there's two shapes that are overlapping and the user touches a point that is present in both of those shapes, we want the topmost shape to be the one that's selected. That just makes the most sense. So what I want to do is reverse my shape list. And I can do that by calling as reversed. And what as reversed does, if we take a look, there's also a function called reversed, but as reversed versus reversed, as reversed returns a reversed read-only view of the original list. So it's not making a copy of anything. He just has some a change to the index. So if you ask for this reversed view to look for item 0, it's actually going to look for the last item in the real list that he's wrapping. This is known as a decorator. He just wraps around the real list and just converts the parameters, passing them to the real one. Now, reversed actually creates a brand new list, so it's going to be more expensive. There are times you're going to need to use that. We'll see that later on. But if you can do a view-only version of this stuff, it's much, much more efficient, especially when you're dealing with a lot of graphic redraws. So by calling as reversed, I'm just looking at it in reverse. Then I'm going to call find. Find is a function that works on a collection, that walks through the collection and locates the first one. Actually, he might be only defined on list. I can't remember if he's defined on collection. Oh, he's defined on iterable. So anything that has an iterator, and collections have an iterator. Iterator is just a interface that has two functions, has next and next. So it's just a way that you can walk through things. So anything that has an iterator, you can call find on. He'll return the first thing that matches the predicate that we pass in. This lambda is the predicate. And the way he works is the last expression in that predicate is going to be the one that is used to test each element until we find something that matches and then just return it. It's just a lambda like anything else. We take a look at find. We'll see that this predicate is just a function that takes an item of the list and returns true or false. So inside here, what I want to do is check to see if the point is inside the shape. So the shape takes place starting in the upper left corner of its own offset for this shape size. And what I'm going to do to make this a little simpler is I'm just going to normalize the shape's position as though the shape were positioned. What we're going to do is we're going to normalize it, treating it as though the shape that we're looking at is at 0, 0. Then all we need to do is check to see if this offset is within the space from 0 to shape size px. It's just a little bit easier. It doesn't do a whole lot. So it's very similar if we translate when we're drawing things. When you translate, you're moving the paper such that the translated point is treated as 0, 0. So I'm going to say val normalized equals offset minus shape dot offset. And actually, we're going to pass in the parameter there. I could also have said it.offset and it works just fine. This is showing an error because that's not a Boolean expression. And we still have some more that we're going to do here. So now I'm going to do my Boolean expression. So I'm going to say normalized.x is greater than or equal to 0. And normalized.y is greater than or equal to 0. And normalized.x, well, let's try actually putting in greater than or equal to proper there. There we go. And normalized x is less than or equal to shape size px. And normalized.y is less than or equal to shape size px. Now this is not super efficient because we're walking through this list every time. Okay, so there's our find at. What I'm going to do now is when we start dragging, we're going to try to find which shape exists at that spot. Now I'm going to need to keep track of which shape is being dragged so that I can not deal with it. I cannot drag it later on. So what I'm going to do in here is add in a little var drag shape equals null. Let's make him private. And then inside here, I'll say drag shape equals shapes.value.findat finger shape offset size. There we go. Now, if we find that, let's actually do it this way. If we actually find something, I want to actually do a drag on it to start with. So I'm going to add in an apply, and I'm going to say drag finger. And let me explain why that's important. When we start a drag, the user is going to be pushing their finger down on the screen. And in order to determine the difference between a drag and a tap, we have to figure out a way to determine what's the difference between a drag and a tap. Because if the user pushes down and lets go in roughly the same spot, we're going to treat that like a tap. But if the user pushes down and moves a certain amount and then lets go, we'll treat it as a drag. So we need something that's going to distinguish. That something is an amount of space called touch slop. And touch slop is the way that the system says if the user hasn't moved at least that amount of pixels, I'm going to consider it to be a tap. And that's because fingers are incredibly imprecise. When somebody touches on the screen, it's very unlikely they're going to let go from the exact same spot they touched. They're probably going to move. Now, that's the actual official term of it, by the way. But it is. I really like the sound of it. It's really unlikely that they're going to touch and release from the exact same spots. You can't just say if they haven't moved. So we apply this little bit of slop, and each device manufacturer comes up with their own definition of what that amount is. And I can't remember what the common value of it is. It might be 24 pixels or something, or 24 dp. That actually seems a little high. It's probably lower than that. It's probably maybe around 8 dp. So what it's going to do here is this start drag is going to tell us where it detected that pixel movement to be greater than touch slop. So this first offset we're going to get is where the user dragged to enough to be outside of touch slop. This is going to be, a little bit tricky later on. We really want to make sure that we understand where they initially tapped, because we're losing some information here. We're losing the initial tap location on the screen. We're only knowing that it's a drag after they've moved a certain amount of space. Think about it this way. When they're dragging a shape, what if they clicked really, really close to the edge of the shape and then move outside of the shape? And let's say touch slop is actually more space than moving outside the shape. By the time they let go, this finger is going to be too far. It's going to be outside of the shape. So our find at's not going to work for it. We're going to have to fix that in a minute. But let's continue on for a moment just so you can kind of see where I'm going with this. And we'll talk about fixing that in a minute. But I just wanted you to understand what the problem is there. So there's our start. The idea is look up the shape where the user pressed down and then drag the shape to the location that they're telling us the drag started. Now, the actual drag function here is pretty simple. He's going to say, if I'm dragging a shape, so this drag shape here, then I want to move it to this current offset. So we're going to start off by saying drag shape let. And this means if we have a drag shape, then I'm going to say shapes.values. I need to define a new version of the map with the shape modified. But if we take a look at shape here, all of his properties are vals. I can't update them in place. So what I need to do is create a brand new instance of the shape with a new value. So, go back to a view model. What I need to do, shapes.value is a list. I'm going to create a new list with the shape in question replaced. So I'm going to do that by saying shapes value equals shapes value dot map, because I want to actually change whatever shape. Oh, come on. What did I do with I must have accidentally hit the wrong key there. There we go. Let's call it existing shape. So we have existing shapes in the map. If the shape that we're looking at is the shape being dragged, then I want to replace it. Otherwise, I'm just going to keep using the existing shape. So we'll say if existing shape equal shape. This is reference equality. When you use 3 equal signs in Kotlin, you're saying, is it the same object that's being pointed to? Versus equal, which just uses the equals function to determine if they have the same value. So in this case, I want to say, is it the same exact object? The problem is that multiple shapes could have the same value. You know, somebody dropped 2 shapes exactly on top of each other, and they're the same type of shape. They could have the same value, the same offset, and the same shape type. So we're looking for reference equality if it's the actual shape that we're dealing with. Else, if it's any other shape, we're just going to use the existing shape. Now the replacement shape is just going to be a copy of the original shape moved to a new offset. So I'm going to say inside here, shape.copy, and that function is defined automatically because it's a data class. And I'm just going to replace offset equals whatever the new offset is, the finger. All the other properties that are inside there, in this case the shape type, are automatically copied over. We're just modifying that finger spot. So this creates a brand new list. It's a copy of the original one, but I'm replacing the shape that I was moving. Now it's a little unfortunate because drag shape is pointing to the old shape that we just replaced. So what I want to do is reset drag shape to the new value. So I'm going to take that copy and I'm going to call apply on it to do some initialization. And I'm going to say drag shape equals this. So this creates a new object, a new shape object. I'm going to take that new shape object, pass it as a this into the lambda, and then set drag shape to it. Now we could do very similar type of thing by saying val new shape equals shape.copy, and then say new shape, drag shape equals new, oh, come on. Drag shape equals new shape, and then return new shape. So we could do this, and it really does the same kind of thing. We create the object, initialize it, and then return it. Apply lets us do all that together. Let's say roughly equivalent to, I'm going to say equivalent to, not just roughly. The reason I'm saying equivalent to is that the apply is basically creating a local variable for us, which is that new shape, and then using it inside here. It just, instead of it really being a separate local variable, it's passing it in as the receiver to that function. Okay, so this will replace that spot for us. Now end drag is pretty simple. I'm just going to say drag shape equals null. And I think that's all I had to do for him. Yeah, that's all I need to do for him. And now we're in good shape, so to speak. So we've got all these fun little functions defined here. Now we need to actually pass them in to the graph. So let's come up to our parameters. I'm going to say on start drag and oh, come on, fingers. It's going to be an offset and then a float. It's being passed into him. And do something with it. And then on drag is just going to take the offset. And then on end drag is not going to have any parameters. So we got those 3 guys passed in. Because we're going to be using it inside of a gesture detector, I need to make references for these 3 guys as well. So it's fine when we're doing those references. There we are. So this is going to be on start drag ref. There we go. So we got those three references. And now we can actually use those three. So we'll take a look at our select here. We've got on drag start, who this guy, if we float on him, only takes an offset. Our on drag start takes that extra parameter of the size. So I'm going to need to call it inside a lambda. I can't use a method reference. So I'm going to call on drag start, on start drag ref. Maybe I should have. Let's rename these guys just to be consistent with what they got there. On drag start, on drag end. There we go, that's better. Okay, so I'm going to call this on drag start ref, passing in. I might as well just be explicit about this. Finger and shape size px, so we can look him up. On drag end, he doesn't take any parameters, I don't think, does he? No, so I can use a reference on that one. On drag end ref. There we go. And on drag cancel is going to be the same thing. We don't need to distinguish between a cancel and an end. We're just stopping whatever the drag is in either case. So on drag is going to need to call on drag. I only use that offset, so I'm going to pass in change dot position. There we go. So those should be our, just double check that I got those right. Add a little comment in here, say drag amount isn't used. Yeah, that looks good. Okay, so now we got those guys set up. The last thing we need to do is pass those three functions into the graph. So I'm going to go back to my main activity. And let's specify remaining arguments. Ooh, that's a lot of extra remaining arguments. Get rid of all these. A lot of those default. So we'll say view model, start drag, view model, drag, and view model, end drag. There we go. Now let's see if we get lucky. So we'll drop some shapes down, go to select, and let's try dragging this square. So right now I'm holding down. I'm going to start moving, and boy, he's moving around. But notice how he looks here. Sometimes he's behind things, sometimes he's in front of things. That's not super consistent. And I'll do the same thing with this guy. He's in front, behind, in front, in front, in front. Maybe the circles, let's see how he goes. Behind, in front, behind, in front. So that's a little effect that I really don't like a lot. So what I'd like to do is set it up so that whatever you're dragging is always pulled to the top. And to do that, all I need to do is remove it from the list and add it back to the list. So by removing it from the list, it's no longer there. Adding it at the end, make sure that it's going to be the topmost thing that's displayed. So let's go back to our view model. And when we're doing this guy here, which is the actual dragging around of the shape, instead of doing this mapping that I set up here to replace the thing in place, I'm just going to remove it from the list and re-add it. It ends up being quite a bit simple, actually, simpler. So I'm going to say shapes.value equals shapes.value minus shape plus whatever the new shape is. So I'm going to pull this guy up here. And, whoops, there he is. let's say val new shape equals, and then the rest of this can just go poof. So that's much, much simpler. Put a little comment here. Ensure the new shape is on top. Looks better when dragging. Now I just wanted to show that to you so you can kind of see if you ever need to replace an item of a static list or a list that it's non-mutable list. This is how you could do it. You make a copy of it replacing the existing item like that. Okay, so now let's try that and see how that looks. So we'll drop a few things here. Circles, triangles. The triangles should be on top to start with. Let's try the squares. I'm going to click on this one and drag him. And notice how now he's on top of everything because I moved him to the end of the list. And then triangle, he's on top of everything. And circle, he's on top of everything. So that's working just great. Now there is one little thing that I'm not too keen on. And that's, well, it's kind of a combination of things. There's two items here. One, knowing which shape was actually selected. If you're really, really close to the edge and you click and start dragging, notice how that one, I was right on the edge and I started dragging, but now it's not being done. Let me just try that one more time. I get right to the edge of it. I'm holding down, I'm dragging, and notice how he's not being moved. That's because I'm right at the edge and the touch slop doesn't kick in until I'm outside of the space. So what I want to do is when that touch slop kicks in, I want to take a look at where I put the mouse down, not where it's starting the drag. So to do that, I'm going to need another gesture detector. So if I go back to my graph, and we'll look at our select. Right now we have this detect drag gestures. I'm going to add in a detect tap gestures, but I'm not going to use the default one here, which is looking for tap. If I float over him, well, it's off the screen. By default, it's tap, which means it's a press and a release. That's considered a tap. What I'd like to do is just watch for press. And if it's been pressed, then I'm just going to keep track of where it was pressed. Okay, so let's define that one. I'll come in here and I'll say on press equals, and he has a single offset being passed in. I'll say finger. And what I'm going to do here is call on press in the view model to keep track of that. So let's come up here and we'll define a new on press. We're just going to take an offset. And I'll come in here and I'll call on press. Well, he needs to be a ref because I'm inside of a gesture detector. So I'll say on press ref is on press. And then we'll call on press ref, passing in the finger. There we go. So now in the view model, let's fix that. I've started my drag and all that fun stuff. Let's have a private var initial finger offset. So where did it get pressed? Let's actually have it be offset 0. And then I'm going to define a little fun called finger down, which is going to take a finger. It's going to be an offset. And then we're just going to say initial finger offset equals finger. There we go. And now I'm going to tweak the start drag a little bit here. Instead of doing a find at finger, so where it detected the touch slop was exceeded. I'm going to change this to be initial finger offset, which should allow me to pick up that thing even if I moved outside of it. Okay, so we've changed this to be initial finger offset, which should take care of that touch slop issue. Now if I run this, oh, I didn't pass it in yet. It was on press. View model, finger down. And that should work now. So we'll drop some shapes. Let me try moving this. I'm going to get really close to the edge again here. And I was a little too far on the edge there. Come on, get in there. Oh, now he's not working at all. What did I do? So detect tap gestures on press ref finger. That's calling on press. On press takes the offset. On press is finger down. Finger down sets initial finger offset. And then the start drag is looking at initial finger offset, and so on. So let's use our logcat here to actually take a look and see what initial finger offset is when we actually start dragging. Oh, did I drag enough? Maybe that's what happened. Oh no, I tried dragging a lot and it wasn't going. Yeah, so that's definitely not a touch slop issue. Let's see. What's going to happen if we do a log on this. We'll say log.d and we'll say initial offset equals $initial finger offset. Let's see if that is going to help us. Oh, I'm getting nothing. Interesting. What did I blow up? Let's come back to the graph. So I got my on press. Let's just quickly change that back to finger. It doesn't look like this is getting called though. Well, unless, no. I did rerun it, didn't I? Yeah, he's not getting called. Huh. Oh, I know what I did wrong. Let me come back to the graph. I made a silly mistake. Yeah. Each pointer input can only have one gesture detector associated with it. You have to actually call pointer input multiple times. That is my issue. So I'm going to move this one up here. And then I'll just indent that one a little bit. And now it's going to work just fine. But let me fix this one back to, I don't need that. Change this one back to the initial. There we go. And now this will totally work. So I'm going to get right up to the edge of it. Come on, get there. There we go. And oops, I moved him off the screen, so he canceled. Oh, I did it again. I'm not going to be able to pick him up again. He's gone. So now my drags are working just fine on him. But notice what happens when I'm clicking here. If I'm over on this edge here, let's say I'm by here, and I'm going to click and hold. I'm going to start to drag. Watch what happens to the shape when he starts moving the first time. Notice how it kind of pops, and now my mouse or my finger is at the upper left corner. So I'm actually dragging the upper left corner. What I'd like to do is keep track of the relative offset of where I initially clicked, and then use that to offset the position. So to do that, I'm going to take wherever my finger is, I'm going to subtract the offset of the shape. And then when I'm moving the shape around, I'm going to subtract that difference from it, which is going to move the shape back. So it'll basically keep a pin in where I'm clicking on the screen or where my finger is. So I'm going to go over to my view model. And where's my drag? There's my drag. We've got my initial finger offset. What I want to do is calculate the difference in that finger offset from where the shape originally was. I'm going to call that drag shape offset. And then what I'm going to do, when I do my start drag, I'm going to calculate that. Yes. So my start drag down here, where I do my apply, before I actually start dragging it, I'm going to come in here, I'm going to say drag shape offset equals the initial finger offset minus the offset of the shape. And then when I'm doing my drag down in here, when I do this offset, I'm just going to subtract that drag offset from it. So the new version of the shape, I'm actually going to move him up and to the left from wherever my finger was. And that should make it look a little bit more reasonable. So let's drop that shape there. I'm going to try clicking in this corner down here. And as I drag, you'll notice that now it stays relative to where I clicked. I can do the same kind of thing for the upper corner. I basically just kind of created a pin. Now you're noticing that the shape is kind of lagging a little bit. That's because I'm dragging in this view. If I actually did it on the screen here, you'll see that I'm actually dragging on my phone screen. You'll see that it's actually keeping right up with me. It doesn't have that lag. The lag is only because of the communication between this mirror and the phone device. Okay, any questions? So that makes things look a little bit nicer there. Now I'd like to do one more little thing with this selection. I'd like to say if the user taps on something, let me have it highlight every other shape that's the same shape. Now highlight, nice and vague term. You can have it mean whatever you want. You can flash the background, you can change the outline. I'm just going to change the outline for it. So if I go back to my graph, I'm going to add in not only an on press, I'm going to add in an on tap. And on tap, I need a comma, is going to take a finger location, and I'm going to call on tap ref, which I'll need to define, passing the finger. Now note that a tap is a tap and a release within ViewSlop. So if all I did was press and then start dragging and I drag past ViewSlop, on tap won't be called. If I press down and release without moving at least touch slop, on tap will be called. So I'll get my on press and my on tap called. So on tap ref, let's do this guy here. Go up to the top and let's do an on tap. Let's go to our view model. And the tap in the view model is a little bit more interesting because we're going to need a little coroutine to do some interesting things with it. So let's come in here and I'm going to say fun, highlight. And to make this thing blink, I'm going to have my view model set a property inside of a flow that will, am I using a flow or am I using, yeah, I'm going to have it set a Boolean, or not a Boolean, a shape type inside of a flow to say what shape is currently selected, what type of shape, whether it's a triangle or a circle or a square. That's nullable. If it's null, I don't highlight anything. If it's not null, when I'm drawing things in the UE, I'm going to give it a different border. So let's come up here and add in here a highlighted shape type. That's going to be nullable. Okay, so that should be good there. So highlight is going to take in it, very similar to what we did for starting a drag. We're going to take in the offset and a shape size. I'll go ahead and say finger. You guys seem to like using fingers. I'll say finger. Could be either way. I'm not really particular to it. So let's say shape size px. And then inside of here, we're going to start a coroutine, which is going to set the shape size, then set it to null. Set the shape type, set it to null. Set the shape type, set it to null. Set the shape type, set it to null. We'll make it blink 3 times. So I'm going to need to use a view model scope to launch a coroutine. And this is a coroutine that doesn't do any file I/O behind the scenes. So there's no blocking I/O happening. So I'm just going to use a default dispatcher, which is just like a normal thread. It hasn't been optimized for any specific purpose. And then inside here, I'm going to say if there's a shape where I clicked, then I want to make the highlight blinking. So the first thing I'm going to do is that find, let me just copy that line. Where are you? There he is. So we'll do that find at, and this is going to be at finger instead. And I'll call let on him. There's a shape. And if that's found, I'm going to do 3 times. There's a parameter being passed in here. I'm going to completely ignore it. I'm not using it for anything. But I could use it if I wanted to. But I'm going to say take that highlight shape type and set its value to shape.shapeType. And then we'll set it to null. Now I don't want to have them happen right behind each other like this. I want to put a little bit of a delay so we can actually see the blink. So I'm going to say delay for 200 milliseconds and delay for 200 milliseconds. Note that there's going to be an extra delay at the end of the 3rd cycle before it actually kills the coroutine. Not a big deal. If you really wanted to, you could check to see, am I on the last repeat? So is the repeat value 2? If so, don't do this last delay. 200 millisecond delay isn't going to kill anything. This is happening in a separate coroutine. Okay, so this should kick off a little coroutine that blinks the shape type on and off. I'm going to need to pass him in. Let's go back. I think did I pass in on highlight? I don't think I did yet, did I? Oops, I need offset and float. Why does it feel like I did? But oh, I passed in tap or on tap there. Oh yeah, I already did that. He's taken care of. But the on tap should also take in a float for the size. So let's come down here and pass him in. Otherwise, I can't actually figure out what I've clicked in. shape size px. There we go. Okay, so that should call it. Now we just need to wire them together in our main activity. On tap is going to be view model highlight. Now we're also going to need to pass that selected, the highlighted shape type in here. Let's pass him in, highlighted shape type. And I'm going to have him start as null. And let's pass him in here. Let's put him in here. So highlighted shape type equals highlighted shape type. Let's create a parameter for him. Go into the graph. Where did he add him? He added him at the end, didn't he? I'm going to move him up to the top. Okay. And then, where is this guy? So the tap should call him. I've got that highlighted shape type being passed in. I'm not using it yet. Let's go down to where I'm drawing. And for each shape here, I want to change his outline. So I'm going to say if shape dot shape type equals highlighted shape type, else shape outline color. I'm going to pick a different color here if it's highlighted. So shape highlight color. I need to pass him in. Highlight. Oh, come on, learn to spell, Scott. Highlight. Oh, yeah. There we go. There. That looks reasonable. So let's see, where do we have a color here? Let's say shape highlight color. Let's say magenta. Caller could change it if they want to. So now I just need to take that color and use it. I'm going to say outline color equals. I need to pass it in to each of these functions. So let's come up to draw a circle. And we'll say outline color equals shape outline color. So we'll just default it. And that was draw a circle. Let's see, draw a line. Let's go up to draw a square. And draw a triangle. And then down here, where it says shape outline color, I'm just going to change it to outline color. So we'll use that parameter instead. And this one down here. And finally, we'll pass them in. Outline color equals outline color. Just like that. And let's go ahead and add names to call arguments. There we go. Okay, let's see if that actually works. So we'll drop some triangles. Or those are called squares, in case there was any doubt. And now when we select, if I click on the square, it makes him blink. If I click on the triangle, it makes them blink. If I click on the circle, it makes them blink. So now let's deal with the lines. We have this line operator, which is going to let us drag lines in between things. Let's add in a data type for him to start with. And a line is going to have shape 1, which is a shape, and shape 2 is a shape. And the way I'm going to want to have this work is when you start drawing a line, you're going to drag it from the starting shape. As you drag, I want the line to extend to where your finger is until you let go. If you let go on top of another shape, it's going to fill in that second shape for the line. But I want to do the same kind of thing here where this data class can't be changed. So what I'm going to do is make this second shape nullable. And when you initially draw the line object that you're using is going to have a null passed in for shape 2. When you let go, we're going to replace that line with one that has the second shape filled in. For this to work, we're going to be keeping track of a shape, a line that's being a line that's in progress, and the what am I trying to say here? Oh, wherever your finger location is, we're going to keep track of that in the UE so that we know where to draw that line to. So in our view model, I need to have some support to deal with lines. Let's go back to our view model, go up to the top. Going to add in lines. So we'll keep track of all the lines that are being drawn. There we go. And let's keep track of a line that's currently in progress, kind of like we did for these other ones. So we had some of the little temporary variables for dragging. I said, what's in progress here. I'm going to go ahead and do the same kind of thing down here for the lines. I'm going to say private var, line in progress. Okay, so this one's going to be initially null. So we're not currently working on a line. Let's do a start line function, which is going to look kind of familiar parameter-wise. Shape size px. And we're going to do that same kind of lookup that we did before to see, is there a shape? Oh, might help if I move that inside there. Is there a shape where the user clicked down? If so, I'm going to do some stuff with it. So I'm going to say line in progress equals line, passing in that shape, so that's the first shape, and I'm not passing in the second shape. Once I have that, I want to add this to my lines that I'm keeping track of. So I'm going to apply, and I'm going to say lines.value plus equals this. So now that lines is going to get updated. The user interface will get recomposed, which will have the this new line in it. And this one is only going to be a partial line. Now let's deal with end line. And we're going to have to do the same parameters again because there's another shape that we're going to be looking at here. So we'll do the same guy here. So if we have that end shape, well, actually, we also want to, outside of here, say if there's a line in progress. If it's not a line in progress, then end of line just doesn't do anything. So if we find an end shape there, let's call him end shape just to make him a little bit more clear. Then what we're going to do is replace that line that we were working on in progress with a real line that has both parameters. So I'm going to say lines value equals lines value minus the line that was in progress plus a brand new line. So we'll say line.copy shape2 equals end shape. If there wasn't a shape in progress, we want to get rid of that temporary line. So I'm going to say question mark colon, that's Elvis. If this result was null, we're going to run a block. And this guy's just going to say lines.value minus equals line. So we'll just remove the line. And I can go ahead and say line in progress equals null. Okay, so far so good. So that'll end our line. And let's see, we'll do a cancel as well. So in this case, remember when we were doing a drag, we didn't care about a drag cancel. Regardless of dragging, canceling or ending, it was the exact same behavior. But in this case, ending versus canceling makes a big difference. Canceling is just going to remove that line. So if I say cancel line, I'm going to say line in progress, let line, and we'll say, I can just do this. And then line in progress equals null. So that's just some cleanup that we're doing there. Okay, so far so good. So now back to our graph. We're actually going to use this stuff. So we're going to have shapes and we're going to have lines coming in. And we're going to need a color for that. So let's see, where do we got our colors? Let's do a line color and maybe a dark gray. And then I need a couple functions for line start and line end and line cancel, kind of like we had here. So on line end, on line start. On line cancel. So line start took an offset and a float. Line end took an offset and a float. And cancel took nothing. So I think that's only three we're going to need there. Let's set up some refs for those like we did before. Why is that one not being used? Did I accidentally say on drag? I did. Let me fix that one. Okay, so we're going to have on line start ref, line end, and line cancel. On line start. There we go. So now, there's our draw line right there. So we have our base modifier. We're going to add in a pointer input. And we're going to need to do a couple things. We're going to have to deal with a press to keep track of the initial press like we did before. So detect tap gestures. And he's going to be an on press, not an on tap. So on press equals finger. And we're going to call on press ref, passing in the finger and shape outline size. Shape size px, yeah, that's what I want. Oh, that one doesn't, oh, that's just keeping track of where he was pressed initially, so that's fine. Okay, so now we need let me just copy the other one here. Yeah, this guy. Come up here. Oops, I almost did it again. That's a bad knockoff of a Britney Spears song, by the way. So we'll paste him in there. So drag start. This is going to be a online start. On drag is going to be we'll come back to him in a second. On drag end is going to be on line end. on drag cancel is going to be on line cancel. So let's see, line end ref, isn't that what I called it? Oh, I'm not passing in the parameters. Okay, so we'll pass in so we need to have a on drag end doesn't get a coordinate passed to them. So we have to keep track of the last place that the drag was. So we're going to keep track of that and pass it in there. So I'm going to set up a little temporary guy here. Where do we got some buckets? I thought I had one up there. Oh, wait a minute. Oh, I didn't draw my lines yet. That's why he's not used. Okay, so we will add in here a var temp line end by remember. And this is going to be mutable state of offset.0. So we're just going to keep track of the drag for the finger inside of here because we don't really care about it inside the view model. There's the one. This is the one for drawing a line, right? Yes, okay. So here we're going to say temp line end equals change dot position. We're just keeping track of that. And then here we're going to pass in temp line end. Now we're also going to use temp line end when we're doing our drawing below in just a minute here. Okay, so this, just make sure I used refs on all these ones. Cancel ref, end ref, start ref, press ref, good. Don't want to do that again. And so now we're down in our canvas here. Right now we're drawing shapes. We need to draw lines. The question is, do we want to draw the lines first or do we want to draw the lines second? Well, let's take the case of drawing the lines after the shapes. That would mean the lines appear on top of the shapes. And what we'd ideally like to have happen is the lines emanate from the edge of the shape rather than inside the shape. That would require a good bit of calculation to figure out where that intersection is going to be and then crop the line at the right spot. Trust me, I've done that in the past when I took some graphics classes in the 90s and you had to do everything by hand. It's not fun. So what we're going to do is we're just going to take advantage of the painter's algorithm. We're going to paint the lines first centered on the shape. So the line is going to start at the center of the start shape, and it's going to end at the center of the end shape. If we do that and then paint the shape on top, it's going to look like the line was going toward the center of the shape, but stops at the edge of the shape. So it's going to look really nice and clean, and we don't have to do any calculation on it. So, consider which order you want to draw things in. It makes your life a lot easier. So I'm going to say lines for each line. And inside there, we will do a draw line. And let's do this one here. I'm going to say color equals line color. And now that guy's being used. Start equals line dot shape 1. And I'm going to need to have some way of getting the center. So I'm going to create a little get center function in a second here. And then the end is going to be shape 2. Why do I have 2 of those? Shape 2 gets center, which could be null because shape 2 could be null, right? So I'm going to need to have an alternative. So if there's no explicit shape 2 defined, I'm just going to use that temp line end, so where my finger happened to be. So we'll say temp line end, just like that. And then we're going to have a stroke width on this, which is going to be shape outline. So now let's define that get center function. And he's just going to be whatever the offset of the shape was plus the half shape offset. So that's just going to move us to the center of that guy. Boom, nice and simple. So now we've got some drawing. Let's see if, oh, I didn't pass in yet from the main activity. So many moving parts. Specify remaining arguments. Lines on line cancel, blah, 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 blah. Line color, we'll leave line color by default. I'll fill that in a second. Actually, let's come up here and just do that. Lines, lines. And then this is going to be view model, start line, view model, end line, view model, cancel line. There we go. Now let's try it. Okay, we'll put some shapes out around here. Let's go to drawing the lines. And if I drag there, note that as I drag, it's keeping track of where my finger was. Since I went off the screen there, it did a cancel for me. Okay, and let's see what happens if I drag a shape. Click. Let's drag this blue shape. Uh-oh. That doesn't look so good. Something is not too keen here. Let's take a look at our view model and see if we can figure out what's going on here. So we have this drag function. And what the drag function is doing is he is going to be moving a shape. But notice that we're calling shape.copy. Shape.copy creates a new instance of a shape. But in our tool type, line is pointing to a shape. So what ends up happening is as soon as I start moving that shape, this shape pointer becomes stale. It's pointing to an object that's no longer being drawn on the screen. That object still has an offset, which is why we see those all still pointing to that one spot. But it's not being drawn on the screen anymore. The new item is being drawn on the screen. So what we need to do is, instead of having the line directly point to shapes, we want to indirectly point to them. So we're going to create an ID for the shapes and then look that up. So let us give the shape an ID here. Let's say val ID. It's going to be a string. And we'll just do the same thing we did before. We're going to use a UID to make sure it's unique. And then down here, I'm going to change this to be shape1 ID and shape2 ID, which is just going to be strings. And all hell is going to break loose now. Let's go back to our view model and take a look at what we got. Now down here, we have a line where we're creating a line for shape1 ID. I'm just going to pass in shape1 ID. That was easy enough. And then this one, same kind of thing. So that was easy enough to fix up there. But if we go to our actual graph, this is where things are getting a little tricky. We need to actually look up the shapes. Now we can do this a couple different ways. One way we could do is create a helper function that walks through the list of shapes and then returns the shape that matches an ID. That is not a great idea. If you have a lot of shapes on the screen, that could really slow things down. So what I'd really prefer to do would be to have a way to look up the shape by its ID. So if I have a map that associates shapes by IDs, then I can just look them up. And it's a very fast lookup. So I can do that a couple different ways. I can go into my view model and I can define a corresponding flow of map from string to shape. And that would work great. So then I have my shapes for giving me an order of the shapes to draw, and then I have the map for the quick lookup. Then I just have to make sure I keep them straight. Now, fortunately, there's actually a slightly easier way to do that. There's a type called linked hash map. And linked hash map will keep track of the order in which the shapes are inserted. it will also give us that lookup capability because it's a map. So I'm going to change this list type to a hash map type and initialize it to a linked hash map. So I'm going to come in here, and instead of this being a list, he's going to become a map, not a nap. I need a nap. String shape, and this is going to be a map string shape. And instead of initializing an empty list, I could say empty map, but then that's going to initialize it just to a normal hash map, which doesn't have that property of preserving the order. The big difference is that when you say map.values, if it's a linked hash map, that will be ordered based on the order of insertion. As opposed to if I used a tree map, then you can provide a comparator which gives you a sorting order on it. And so then when you walk through the values, they'll come out in a sorted order based on the comparator you pass in. The normal map has no guarantees whatsoever. It can return that collection in whatever order it decides it wants to. And that's just so that it can optimize it however it wants to. And you're basically saying you don't care about the order if you use a straight old hash map. So I'm going to change this one to be a linked hash map. That'll create that there. And now you'll see that I have some errors here because it's assuming things are a list. I can no longer simply add a shape to the list. What I'm going to do is I'm going to add an entry to the list. So I'm going to say shape.id to shape. This creates a pair object. When you add a pair to a hash map, it's adding it into the hash map, just as though you said hash map dot put, passing an item into it. So in this case, I'm creating this pair, adding it to the hash map. It creates a new hash map with that new entry in the proper order. So let's see what's next here. So the find at is a little bit different here. So instead of find at being on a list of shapes, it's going to be on a map string comma shape. And now, unfortunately, there is no as reversed in the in that list. I wonder if I explicitly cast it, if I can do that. So if I said this as linked hash map, I wonder if he has a as reversed. Oh, dot values. No, unfortunately, he does not. So I will need to create a, that's actually disappointing that it doesn't have that values on there. I guess the problem is because values is a collection, if I just float over it, you'll see it's a collection. You really can't see it, but with a collection, all you know about it is that it's iterable. You can ask it for the next item, the next item, and the next item. Therefore, having that view on it that just translates the index to size minus index, we can't index things in an iterable. So we need to say values dot reversed, which is actually going to create a new list, unfortunately. And that's okay because this find at isn't used all that often. It's only when the user is actually clicking. Boom, that should work just fine. Let's see, what is this other one that's complaining? Oh, there he is. So adding that shape, we need to do the same kind of thing here. We're going to remove the shape. Now in this particular case, we want to remove it based on its ID. So I can say shape.id. When you say map minus a key, it actually removes that item from the list by its key. But I want to, again, add another pair. So I'm going to say new shape dot ID to new shape. Boom, there we go. So that one's a little less direct. We're removing the shape based on its ID, and then we are adding a new pair that associates that ID and the shape. So the order should still be preserved here. So let's see, we need to fix this up in the main activity. So instead of empty list, empty map is going to be the default. And in graph, shapes is going to be a map from string to shape. And now we'll see down at the bottom, there are some stuff we have to fix up. So here's where we were actually looking up the shape before to get its center. So these have become shape ID, which are now strings. We're going to actually look those up inside shapes. So I'm going to say that guy. Oh, let's see if I can get my finger straight here. And then same here. Oh, the shape ID could be null. So actually I want to reverse that. So I'm going to say let. So if the shape ID, ooh, I have a square bracket still. So if the shape ID is there, then I want to actually look it up. So I'll say shapes.shape ID. Then I'm going to do the get center on it. And again, let me actually break this down a little bit. Like that. Okay, so look at my shape2 ID, which could be null. If it's not null, go ahead and look up the shape that I'm interested in. If that's not null, which could either be because the shape ID was null or the shape doesn't exist, then I'm going to look up his center. If that's null, I'm going to use temp line end. Now this one up here, I'm going to say question mark get center. That really shouldn't be. If I've coded things right, this shouldn't be possible for this to be null. So I'm going to go ahead and put in a throw illegal state exception. Boo. Shape ID not found. A little note in the graph view model, when I add this new guy in here, when I do the shape.copy, notice the only thing I'm changing is the offset. I'm keeping the existing ID, so I know the ID is still going to be consistent. Okay, so we got that. And now down here, what is he unhappy about there? Oh, I'm calling shapes.forEach. Shapes is a map. When you say for each, it's going to return a map entry, which is a pair. So instead of that, I want to say shapes.values.forEach. And now that's actually going to be my collection of shapes. Okay, so I think that will work. Let's go ahead and try this. I think I got all the pieces. Let's drop some shapes. Let's do some connections. Why is it not there? That was weird. Okay, and now let's try moving something. I'm going to drag this guy. There we go. That's what I wanted to have it do. So it's actually looking that up each time. Oops, it canceled. There we go. And there we go. So that seems to be behaving just like we want it to behave.